So is proud to present Mr. Tony Lempriere.
Thank you. I will be talking about the cost of climate change mitigation in Canada's forests. I'll start first by acknowledging my co-authors listed here. Now, last year, a study was published that looked at the emissions impact of a set of mitigation strategies involving Canada's forests. And in this presentation, I'm going to provide some of the findings of a follow-up study looking at the cost of these strategies in Canada's forests, undertaken with some of the same collaborators. Now, we developed estimates of costs for strategies implemented over 2015 to 2050. We had 7 strategies that we were looking at. First, a better growth strategy involved silvicultural activities like fertilization and reduction of competing vegetation. A planting strategy simulated faster regeneration by increasing post-harvest planting. Third, a better utilization strategy included several different actions. One was higher utilization of wood from harvest cut blocks to increase the wood that was extracted per hectare while keeping the total harvest volume unchanged. Other actions in this strategy were reduced on-site burning of harvest residues and then recovery of up to 50% of residues for bioenergy. A fourth strategy was a harvest less strategy, which reduced the harvest volume and restricted the forest area available for harvest. And we looked at wood products through a longer-lived products strategy, which assumed that the harvest is used to produce a greater proportion of longer-lived products like lumber at the expense of pulp and paper production. We also examined 2 combination strategies in which the longer-lived product strategy was combined with better utilization and combined with harvest less. So in this presentation, I'll be showing results for these 7 strategies. We implemented the strategies across Canada's managed forest, which covers 232 million hectares, as it's defined for the purpose of greenhouse gas inventory reporting. And for this study, we implemented the mitigation strategies in 32 separate spatial units that covered almost all of the managed forest. These spatial units are shown here. They're defined by the intersection of ecozones, which are in color, and the boundaries of our provinces and territories. We had 4 components in our analytical framework. First, the impact of strategies on the forest were estimated with the carbon budget model of the Canadian forest sector. That's the same model that Canada uses to produce forest-related estimates for its annual greenhouse gas inventory reporting. Second, we estimated emissions associated with bioenergy and carbon stored in harvest wood products. Third, we calculated emission displacement effects resulting from substitution of wood for other products and bioenergy. And then finally, we calculated strategy costs by estimating the net present value of the change in forest sector revenue that results from each strategy using a 3% social discount rate. And now we can start to look at the results. Now, strategies had quite different mitigation impacts over time, shown in these 2 graphs, which show cumulative mitigation to 2050 in megatons of carbon dioxide equivalent. The left figure shows mitigation impact in the forest sector, so it's considering ecosystem and harvested wood products, but not displacement. Now, just looking at forest sector mitigation on the left side, we can see that a strategy of harvesting less and producing more longer-lived products appears best, resulting in almost 600 megatons of mitigation cumulatively over the 2015 to 2050 period. However, considering displacement effects changes the conclusion, as shown in the right side figure. Including displacement effects, as shown in that figure, indicates that a strategy of better utilization and more longer-lived products is actually best, resulting in close to 900 megatons of mitigation over the whole period. And that's because this strategy provides displacement benefits from using residues for bioenergy, while the harvesting less strategy reduces displacement benefits. We derive national forest sector cost curves by determining the cost for each strategy in each region sorting the mitigation costs from the smallest to largest across all regions, and then comparing these successively higher cost estimates to the mitigation that was achieved at each cost level. The resulting national cost curves are shown here, and they show that the cost strategy varies substantially across the country and across strategies. Now, individually, costs varied per ton for each strategy up to 150 Canadian dollars per ton and higher, but there was important mitigation at lower costs. Now, not surprisingly, we found that no strategy is the best strategy in every region. In fact, it makes more sense to choose a portfolio of strategies that uses in each region the strategy that maximizes mitigation in that region. The figure on the left shows such a portfolio for forest sector mitigation. It achieves about 150 megatons more in total mitigation than the single best strategy shown on slide 6. The figure on the right shows the cost curve for that portfolio. It shows that an average of about 20 megatons per year could be achieved at costs up to $100 per ton. Now, the figure on the right is showing average annual mitigation over the whole period. And so, of course, there's relatively little mitigation early in the early years and much more in the later years. And that same conclusion can be deduced from the curve on the left. Now, just by way of summary, our analysis shows that it's important to look at displacement effects, and not doing so can in fact lead to strategy choices that are not the best in the long run in terms of mitigation. We found large mitigation potential from the forest sector exists in Canada, but strategies need to be implemented in the near term if they are to contribute substantially by 2030 or later years. We also found that over the long term, forest sector mitigation costs are likely competitive with mitigation costs in other sectors. And finally, we do acknowledge that this analysis was done at a very coarse scale, and it cannot capture the more regional or localized opportunities. And so we have ongoing work that is examining options at a higher spatial resolution. More information can be found in these references. And of course, I'm available for question or comments now or later via email. And thank you.